to this event. Hope you are having fun wherever you are, following the online DevGAMM event. My name is Chema Damak. I'm a technical evangelist at Unity, and today we are going to talk about adaptive user interface and how to use the device simulator to fireproof your UI. I don't know about you, but preparing and integrating a user interface, especially for mobile games, is more and more difficult to test on the hundreds of devices that are released to market each year. We are now witnessing a big boom in technologies and thus different new resolutions to be aware of. So if you are to create a game for mobile and trying to have the perfect user experience, especially when it comes to UI, you'd need to think about the testing phase and gasp at the amount of time you'll spend building on various devices or sending to friends and relatives to have their feedbacks, or at least that's what I did before Device Simulator existed. To show you how this feature works, today we are going to adjust a simple user interface for a fictional game that we're going to call DevGAMM game. It's composed of 5 different parts: the player information, buttons, the inventory, the friends list, and a score. This mockup, provided by our artist, has been added to the scene using some cool UI from a package you can find on the asset store called Ultimate Clean GUI Pack from Game Vanilla. As for the game on the background, it's the karting microgame available on Unity Learn. As you can see, the UI is pretty much the same as the mockup one. Only difference here is that once we change the resolution, you'll notice that the UI doesn't follow. So let's try it. Some of the elements exceeded the canvas that we have, and in other cases, the UI doesn't look like much. Let's go back to our preferred resolution. We could also add some resolutions to our list. So let's try this one. Yeah, that doesn't work well. And actually, I can't even think about another value to add to test it. So maybe I'll look for one on Google or something. Or maybe I could download the device simulator to help me test it on different screens. To do that, simple steps. You need to be working on Unity 2019.3 or above. Go to Window, Package Manager, check Show Preview Packages, and then look for the device simulator, and you just have to download it. Right now I'm up to date, so let's check it. Once this is done, you don't even have to open another window. If you go to the game window, you could switch to the simulator window with a simple click. And that's it. Better than building to see how it looks like, just go to the list of provided devices and switch to another one. So if we want to check on an HTC 10, that works. But what if we want to test on an iPad? Yeah, that doesn't work. This will not only be useful to check your resolution, but also if you need specifications about the phone or tablet itself, the OS, the GPU, the CPU. Maybe you need to test the UI when the device is flipped. So if you have it on landscape left and you want to flip it, like here, you can rotate it and see how the UI looks like when it's in portrait mode maybe, or in landscape right. According to our game designer, we know that this game will only be available for landscape and not portrait. So let's maybe uncheck the portrait and the portrait upside down and now when we try to test it, it will always stay in the landscape mode. Of course, to make it so your build does the same, you'll have to change these informations from the player settings. Go to project settings, and then, because we are on Android, we will uncheck the portrait and the portrait upside down. Another section that is very useful and would be time consuming if we had to do it manually is to change, for example, here, the system language, especially if you have a lot of languages to test, the internet reachability, if internet connection influenced your game, or in this case our UI, and you wanted the testing to happen when the game is running, that would request a lot of attention or some coding for it, if you're not using Device Simulator, of course. If you need a custom device that has not been added yet to the list that we provide you here, you can easily create your own. Just go to the package manager, our packages, Device Simulator, click on View Documentation. If you need a custom device that has not been added here yet, you can easily create your own. Just go to the package and you'll find a link to the documentation to help you just do that. You can either have it with extended information or just the basic one. And to add it to the list, go back to your editor, go to Preferences, open the Device Simulator, and link the folder in here. So let's go back to our UI. We've asked the artist to add more information about the UI so we could have it following the screen. What they've said is to have the avatar being on the top left of the screen, the buttons on the left center, the inventory taking 50% of the left height and 65% of the bottom width. As for the friends list, the request was to make it farther from the right by 2% and having 30% width. We'll do just that. Before modifying the UI, we will check the UI scaling mode that we are using for this canvas. As you can see, we have it scaling with screen size with a reference resolution that is 1920 by 1080. The score element has already been set with the information needed, so we're moving to the player panel. We will need to anchor it with the top left of the screen. We'll select it either in the scene or from the hierarchy and go to the inspector to check the rect transform. We'll change the anchoring to the top left, and because we want the calculation of the distance to be made from the pivot on the top left to the anchor on the top left, we will change the pivot to 0 on X and 1 on Y. So we want it to be from the top left, and we want our pivot to be on the top left as well. Let's position it here. Let's say that the distance will be by 15 pixels minus 15 pixels from the top too. This will assure us that whatever the resolution is, this panel will always be anchored to the top left with a distance of minus 50 pixels from the top and 50 pixels from the left. Let's test this on the first resolution that we had tried first in the game scene, and then on the second wider one that posed a problem. It's very far from the top, so maybe we will change some values to tweak them. Now to the buttons. We'll need them to be positioned compared to the center left anchor, so we'll do the same. Changing the anchoring to the center. Then we take care of the pivot. We will do that from the scene view. We'll see that the panel of the buttons is not sized at the correct size, so we'll take care of that. Given that it has a vertical layout group, the buttons inside it will be grouped compared to the panel that holds them. So let's position it in the right place. We also want the position from the left to be the same as the avatar. Now, if we go back to our preferred size, we'll see that it stays in the center left, whatever the resolution that we are using. Always try to test these mini changes. It can help you a lot. Now to the friends list. The artist specifically needed the list to cover a certain percentage of the screen. To change the anchoring, we could do it on the scene, dragging them and reading the percentages directly in the scene, or for more accurate values, we could do that in the rect transform. So let's start by doing so in the scene. You can drag one anchor and see the percentages change. Let's zoom in if you want. As you can see, the percentages are changing, and if we change the other anchor, we will see that all the percentages are showing in the screen. You can either do this. So you can either do this on the scene or go to the rect transform and then modify the minimum and the maximum value for the anchors for X and for Y. If X is at 0, it means that it's in the left, in the maximum left of the screen. And if it's at 1, it's in the maximum right. If Y is at 0, it's on bottom, and if it's at 1, it's on the top of the screen. So if we do some calculations, we know that we need the friends list to be farther from the farthest right point by 2%. So we know that the maximum X will be 0.98. We also know that the friends list should be 30% of the screen. So if we remove 30% of the screen, we will find ourselves at 0.68. And for the Y, we have 0. It starts from 0 and it ends at 85. Let's try it on the wide range, and as you can see, the friends list got squished a little. If we go to another one, it will get longer, and it will always follow the percentage that we asked for. Same thing is done to our inventory, and even though we don't see the difference for this one, we know that the artist's wishes have been respected. Awesome! Let's test this on the device simulator. Let's try it with the iPad. It's working. Let's try it with the Samsung? Yeah, nice. With the Xiaomi? Yeah, that's perfect. What if we go to the Samsung S10? Oh, wow. The OnePlus. From the OnePlus to the iPhone X? Well, we have a problem here. Smartphones and tablets nowadays present a new challenge for everyone: the notches and the edges. That means that if we want to have an element of the UI in one of the corners, or sometime maybe in the bottom of the screen, we might need to reconsider. Because now we have to put our elements in a safe area. Like this one here. Every device that we have in the device simulator will have its own safe area. You can change the border of the safe area by going to the preferences and then changing the color to green, for example, and then changing the line width. We go back and go to game, then go back to simulator, and we can see that the changes that we made have been taken in consideration. Let's go to another device. To take care of this, we can do two things. Either we say that nothing exists outside of the safe area, so we uncheck the full screen toggle. As you can see, nothing is rendered outside of the area, not even the game that we have here. To apply this feature on our build, we go to project settings, then to the Android one, and we have render outside safe area. We can even either check it or uncheck it. The other solution is to create a script that takes care only of the elements that we need inside of the border. So I simply looked for a script on internet that changes a panel size to be contained inside the safe area and found this one on Unity Connect. I'll show you what it looks like. It actually takes the value of the screen.safeArea, which is a rect, and then changes the rect of the panel to fit in the safe area for each new resolution. Let's go back to our scene, create a panel, add the script to it, and then click on play. Once we click on play, we will see that the panel here, we will change the color of the background to pink and or maybe to blue just to see it happening. So as you can see, the panel here changed, so it fits only the safe area. Even if we change the resolution to something else that needs a safe area, like for example the OnePlus, we will see it following the correct safe area. Let's go back to our Samsung. Yep, that seems about right. It will also be the case for other devices. And if we add the other elements of the UI, you'll see that the changes extend to them as well, given that they will be anchored to the parent, which in this case is the panel, the same way they were to the canvas. So let's click on play. Well, this is great, even though if we open the friends list, we'll find it pretty empty. To test this part of the UI, we'll need to fill it manually. We need to look for the prefab, add it to the content, and then maybe duplicate it a little bit. Then click on play. So we could test the scroll. Well, it's scrolling just fine, but it's not a correct friends list. Now we will have to remove those before building, because if you forget them, they will appear for all your players. Another way to test would have been to create a code that tested this, but also there we should not forget to remove it. To test the friends list, a scenario have been proposed by the artist. They needed us to integrate different states to the friends list. One where the list is filled, one where the player didn't have friends on that game, and another one where they didn't have internet connection. The script that takes care of the UI has already been written. So let's figure out how to use the device simulator in this case without creating further code that needs to be removed later when building. For network reachability, easy, we already have the settings. We already have it in the application settings. So if we click on play, open the friends list, and then change the internet reachability to not reachable, we will see that a message will appear in the friends list. Please check your connection. For the other cases, we could actually develop our own scenario to extend the window. To do so, we're going to use UI Toolkit. Download the UI builder from the package manager. Open it in our scene, and then create our own UI. Right now, we have, for the purpose of this demo, we have the UI already created. So let's focus. Let's focus on it. We have a title, and we have the integer field that will hold the friend count that we want to see in the screen. To add this to the device simulator, we will create a script in the resources called device simulator extensions. In order to add the UI for our scenario into the device simulator, we go to the editor and create a new script. We will call the script device simulator extensions. You can call it anything you want. It's not mandatory to call it like that. So once we open our script, let's remove all these functions go from mono behavior to implementing the interface. Let's remove this. So we will implement the interface iDevice Simulator extension. And to have it, we need to be using the namespace Unity Device Simulator. Once we have our interface and it's recognized, implement the onExtended Simulator function and the extension title. We will do just that. First, we are going to implement the extension title. We are going to call it specific scenarios. Then for the function onExtendDeviceSimulator, it actually takes a visual element that we will call init VE, which means that this is the initial visual element that we will add our UI to. You can see that the visual element is underlined in red. We will need to be using the namespace Unity engine.ui elements. The function in here will help us extend the device simulator using the visual element. I'm not going into details for the UI elements, but I will answer your questions later if you have any. So first thing is we are going to create the UI from the friends list simulator UI document. Then we are going to get the integer field from then we are going to get the integer field from the UI that we have created. You can see it's underlined. We will just quick fix it, and it says that we need also to be using the Unity editor UI elements. So let's use this. Then after finding the integer field, the one that contains the number for the friends that we want to showcase on the screen, we are going to look for our game object in the scene that controls the list in itself. Once we have the UI element in here and the game object in here, we will register the integer to give a feedback to our friends list each time the number is changed. Also, to avoid having it displaying a number that is not correct, we will initialize the integer value to 0. Once our visual element is ready, the next step is to add it to the initial visual element, the one that is in that will appear on the device simulator. So let's paste it, then save everything, go back to the Unity editor and wait for the script to be compiled. Once it's done, you will see that the specific scenario has appeared in the device simulator. It will have the title that we chose for it, the specific scenarios, and it will contain the UI element for the friends list scenario that we have created. So friends list as a title and the friends count as the integer field that we will change. So I could better visualize my UI, I added a JSON file containing some random users just to display them in the friends list. To do so, I used the random user API. So if we click on play, we'll see that if we open the friends list, nothing is in there. But if we change the friends count to 1, we will see a random user appearing to the screen. If we change it to 10, for example, we'll see other users. Less players will appear, or more. Trying the scenario made us notice that some of the players had names with characters that couldn't appear on the screen. So if we go to the scene directly and we check this user, we check its prefab, we will see that the text that is appearing is written in Arabic, which means that the font that we are using doesn't allow Arabic. With the scenario also, we checked if our pooling system works. So in here we have 20 friends that have been instantiated. So 20 prefabs instantiated and added to the content. If we go from 20 to 1, we will see that only one item is active, the other one have been checked as inactive. If we go to 10, it's still working very good. So what if we say that we have 50 people, other players will be instantiated and we still can scroll. Even though once we try showing 50 people in the friends list, we see that the performance drops a little. So maybe go back to the game and show the stats just to check that we have everything in order. A cool trick for you is to open another simulation window. So open just another game window, set it aside, and then change from game to simulation. And if we put it as we want, we can see that the game is appearing in the simulator and in the game at the same time. We can also change the number for the scenario, create new users, and then check the stats. So play around with the number a little and then check the impact on our game. So I guess we'll change the font later. I've created two other scenarios for you to show you how you could leverage this feature even more. One is to fill the inventory so we don't have to go and do it manually in the scene. The other one seemed very important to me. When you test a game, one of the screens to check is a game over. Some games were very complicated to lose. Others were way easier, but whenever I needed to test the screen after integration, if it had animation or sound or maybe different layout for a high score, it became very time consuming. So I created this simple extension to help trigger the game over either with or without a high score. Our game over panel is not under the panel safe area because our game over contains a background that needs to be drawn on the whole scene. So let's see it. Here is our game over panel. We know that it has a background, a game over pop-up, and if we open the game over pop-up, we will see that we have a container having the high score container and the item for the game over. So when we remove the high score container, this is the game over without scoring a new high score, and this is the game over with. Let's put our game over game object back at inactive and focus on the scenario that we will be adding to the device simulator. We've already created the UI with UI Toolkit, and we'll open it in the UI Builder. As you can see, the interface is already there. We have the title like the other one that we had for the friends list. We have a checkbox that ensures if we have high score or not. And then we have a button, Game Over, that once clicked will fire the Game Over panel. Once we know the UI that we want to add to the device simulator, we will do the same steps as the ones that we did before. So let's go to the editor, let's go to our script, Let's open our script, the device simulator extensions. Here we have the first one, and then we are going to create the second for game over. Same steps. First one is to create the UI from the UI document. Then we find the visual elements that contain the toggle for the high score and the button for the game over. We will also create a boolean for a high score and set it to false by default. This will help us use it later on in a function called openGameOver that will fire the game over screen, and that needs to know if we are in a if we have a high score or not. Once we have our global variable, it will be changed following the state of the toggle, so we'll have to register a callback for it. Then we subscribe the function openGameOver to the event for clicked button. Once all of this is done, we'll assign it to the initial visual element, the same one that we used for the friends list. Let's go to the editor. Let's switch to the editor, and once the reload is done, we will see that the game over and the toggle and the button have been added to the scene. So if we try them, we click on play. Even though we know that some elements are inside the safe area, we know that the game over isn't. So let's fire it, game over, and as you can see, we don't have any high score label. If we replay it, click on scored a new high score and then game over, yeah, we will see it. That scenario is very helpful if you have additional informations to show for the highlight, or if you have multiple types of game over, or if you don't want to spend all your time trying the game or writing a code to control it. So it's the same code that controls it in game, but it's fired in another way. It's an event that you add to the click of a button, and then you just click on the button. Now let's move to the inventory scenario. For the inventory, we have a certain number of buttons, the inventory items, and if we go to one inventory item, so we could fake it being filled, we will need to set it on active and then set the item empty on inactive. And yeah, we can do that manually, or we could implement, I don't know, a slider that will allow us to see the inventory being filled item by item. So let's go back to the UI that we've created. The one for the inventory is here. If we double click it, we open it in the UI builder, and then we can see that we have the inventory simulation title and then the inventory capacity. Let's put the item of the inventory back to the way it was before. Then open again our editor, our device simulator extension. This time we will look for a slider. The code is pretty much the same, only the names change. We will change the slider field low value and high value by the values that we will collect from the inventory filler. So if you go to the script inventory filler, we have the function get max item count that will allow us to have the maximum count that is present in the inventory, so we don't exceed it with a slider. And once we do so, we register a callback that will fill the inventory list. Adding the latest scenario to the initial visual element, we save it, go back to the editor, and then just like that, as soon as the recompile finishes, we will see that the inventory section has been added to the specific scenarios that we have. If we move the slider slightly to modify the value of the number of items in the inventory, we will notice that without even having to enter the play mode, items in the inventory will be added and removed following the value of the slider. We can also do the same in play mode. I now have done all the tests I wanted to do without even having to build or play the game. This does not mean that I will not do it on a real device at one point, but that already cut the number of iterations I'll have to do by half at least. Thank you very much for following this session. Hope you now have a good idea on how to use the device simulator package to the fullest, not only for UI, but also for other parts of the gameplay.